So hello guys, welcome to my another video. So in this video, we are going to talk about something unique, special, which you've never heard of. It's like too weird, right? Yeah, something like that. Like in the middle of this video, you'll feel like, what? Wait, what? And at the end of the video, you feel like, now I know. So things work like this. So the universe is made like this. Yeah, we are going to talk about the fabric of the cosmos, like about the space time fabric. We're just going to talk a bit about it because we are just going to talk one part of the space time fabric. Basically, we are going to talk about a theory of relativity. A theory of relativity. There are two theories, one general relativity and special relativity. So, general relativity we have already discussed. That's Albert Einstein's law of gravity, which I made a video upon it. That's the gravity part 2. And this video we are going to talk about special theory of relativity. And general relativity was that gravity is relative. Special theory is that time is relative. Wait, what? And earlier time was said to be absolute. I mean 1 second. One here would be 1 second in USA. One. Yeah, it's one. So time is like same everywhere. If I count one and if a person counts one in USA, it would be same interval of time. It would happen in the same time. Time, yeah. Time is same. The period is same. The interval is same. Then time is absolute everywhere. It's constant. In Earth, yeah. I mean, like if you go like far away, that doesn't happen. Mainly in bodies with higher masses, like not even higher mass. Higher mass like kind of matters, but the thing which actually matters is gravity. Intense gravity affects space time. Yeah, space and time. Space and time. Time. Why space? Three space dimensions, one time dimensions. What? Then four dimensions. So basically, our topics are our subtopics: special relativity, four-dimensional universe, and time dilation. Special theory of relativity states that time is relative according to the gravity. Time is relative to the gravity. So wherever gravity is like there's no gravity at all. Time is smooth, straight. Yeah, but something like sun. Yeah, let's say you're in the sun's surface. I know that's impossible. Something having the mass of sun. You're on its surface. I know it would be like damn hard to even stand. You're there. You're just situated in a heavenly body having the mass of the sun. Intense gravity will bend the fabric of the cosmos, space, and time. Like these lines, latitudes and longitudes. Like latitudes are these lines, longitudes are these lines. Like that, space are these lines and time are these lines. That makes the fabric of the space. So space and time bend at the same time at the same amount. So what will happen? Like 1 second for you would be around something like 1 minute for people in Earth, and mm, around 2, 3, 5 minutes maybe, that much time for people in an asteroid. If people are in asteroid, is that true? Well, everyone says, and like everything works like that, so it's obviously true. Time dilation. So this thing just brings two answers directly, instantly and directly. These talks bring two more ideas: time dilation and four-dimensional universe. So gravity, so time is relative according to gravity. Gravity is relative according to the mass of the body. Yeah, mm, many things, many more. Mm, let's talk about time dilation. That's what we are already talking about. For better explanation for time dilation, the sun is not worthy enough. Asteroids, natural satellites like Moon, Europa, Titan. No, no, close. We require something bigger, not planets, not stars, neutron stars, maybe, but something worthy enough for that specific thing. Black holes. Yeah, black holes have intense amount of gravitation that they light the fastest thing in the universe. Like that's the speed limit of the universe. That's like around 300 million kilometers per second. What the heck? 300,000 kilometers per second. That's per second. Kilometers per second. 1 second, and the speed like two within 1 second, light will go around the Earth's diameter 7.5 times, 7.5 times within 1 second. Then 2 seconds, 15 rounds around the Earth's diameter. Just one, two, too quick, like that fast. It just on and it instantly comes. Speed of light. That is the speed of time. If speed of light itself is bent, then time totally would be bent, which will result in time pause. Time is paused. So if you're like less than even 1 second inside a black hole, inside the event horizon of a black hole, like these are the disks of the black hole where a bit of matter and a bit of energy is orbiting around it. And once you reach the event horizon where even light cannot escape, That's when you need to say goodbye to everything around you forever. Because less than 1 second for you inside the in the event horizon. Let's say you went a bit more inside. The universe would have just, wait, what? But that long time, within that time, just black hole would wholly evaporate. Yeah, you know that black holes like consume matter and shoot them out as radiation. When a black hole is in that state, when it shoots out intense amount of radiation, like too high, something like some, it would be something like a UV ray burst or X-ray burst. Terrible. That radiation is that radiation is called Hawking radiation, named after a great physicist, Stephen Hawking, who is basically a physicist as well as a cosmologist. So black holes turn matter into high amount of energy and shoot out them in radiation. Yeah, then matter turns into energy. So you're made up of matter. All of this is made up of molecules, atoms, subatomic particles. But still, they are all matter. The whole thing is matter. Matter. That this matter would turn into energy. You will turn into energy. Will turn into invisible radiation like light, and you will be shot out like a, a little bit of energy is equal to, I mean, a little bit of mass, a bit of matter mass is equal to damn lot of amount of energy. Oh, then by the time 1 second happens, you won't even realize anything. That also, these things happen only in supermassive black holes, because if it happens in smaller black holes, mm, you'll be spaghettified because of the, if bigger the black holes are, like the gravitational pull won't affect you much. It will just pull you into event horizon, and gradually by the time you reach singularity, I mean, you'll reach singularity and you're gone. Because by the time that happens, outside time is paused. I mean, inside time is paused. So, inside whatever you experience, outside you feel like nothing has ever happened. But everything is happening inside, that also to you. Event horizon, and you slowly get in, and the center of the black hole called singularity, you reached it, you're done, because singularity won't affect much. But by the time that happens, according to outside, according to the space time, the black hole would evaporate. Yeah, the, like, at a point the black hole can't sustain all the matter, so it should shoot out the matter as radiation, so the black hole itself would just evaporate somehow. Um, Wait, so gravity has mass, so black holes have mass, And black holes need space, so black holes are matter. Black holes are matter, bro. Come on. We still don't know. Like, that's why black holes are like too mysterious. Time dilation, just no. Damn. But few people say that because of the intense gravity, it reverses time. That's not possible. That's not possible. Then, like, the black hole would still exist though, but it would just get get evaporated into radiation, plasma, and some energy, basically energy. That's not possible. Time pauses completely. Hmm. Time dilation, wow. But what about four-dimensional universe? Why do we say four-dimensional universe? Because space has three dimensions of it, but time has only one dimension of it. Wait, what? Wait, what? Length, breadth, height. So this is my notebook. In this notebook, I've just written a lot of good stuff. This is my rough note. Hmm. This one I just wrote that length describes how long an object is. Hmm. What do we have? Let's have this pad then. Length explains how long the object is. Long, like its length. It's its length describing like how long it is. How long it is. Breadth explains not breadth. It is bread. Or let's say width. How broad or how wide it is. So length explains how long an object is. Breadth explains how broad an object is. Height. It has height. Yeah, look here. Height. It has height over here. Well, height, that's the third spatial dimension, and that's the last spatial dimension, which explains how high or tall an object should be. Hmm. Oh, then the the tenth dimension describes how an object should be according to the time periods past, present, and future. Let's say time randomly went out. You won't have any future, you won't have 1 second afterwards. Say, wait, what? Then you'll be paused. Your past will, your past identity will go. Your past will disappear, not yours. The whole universe is made by a time dimension. You won't have past, you won't have future, no present. Gone. I mean, present would also go. Hmm. You'll be paused. You won't even be paused. The universe would like even like it would just get disappear. Big Bang never happened. What? Then the universe didn't even form. An interesting paradox. This these things led to time travel and stuff in the 80s and 90s about time travel, time machines. But to disprove that, there was a paradox called grandpa paradox. I'm sure that many of you would know it, but for people who don't know it, just listen. Let's say you have a time machine and you time travel back when your grandpa was a small child. You somehow killed him. You just killed him. Then you then wait, what? Then if your grandpa was killed in his childhood, your mother or father won't be alive. Then you also won't be alive. Then who killed your grandfather? How did he die? But a complicated way to answer this question, which can't probably happen, doesn't make sense in reality though. The answer is you time travel, you killed your grandpa, your mother or your either of the parent is not alive, so you are not alive, so you didn't travel back in time, so your grandpa is still alive. That means either of your parent is alive, they both met each other, you are alive, and you travel back in time, and it just goes on. That's the answer, but time travel can't happen. But you can meet your past and present if the universe is rotating, but it's expanding. The expanding universe, space and time, the fabric is just expanding. So, time is very crucial. And if you need to visualize time dimension, all you have to do is you you just keep a mirror like in opposite sides, like in a barber shop maybe, where mirror is front of you, also back of you. Now you're in a loop among all those realities, you're in one. But weird fact is that every frame or every inside every false reality of the mirror is like every frame of you in every unit of time. Unit of the SI unit of time is 1 second. So every second is like one frame. It's like it's like a flip book. Like you'll just randomly take a page, or let's say it's like a file which is a group of pages where it's supposed to be full of animation. You just take one page and next page. That's like 1 second of one person's life, or one nanosecond of a person's life. So your past till your future is already set on, and you're in one frame of it, traveling to other frames. But the one doubt I always have is, does time come from future till us and go back to our past, or do we go from our past to our future? Like, let's say time is like coming like this. Let's say I said hi, and that same and that same dimension went to my past, and let's say 1 minute got over, and 1 minute later in my past, that time dimension is going passing through like this to my 1 second, to my 1 minute past of myself, and I'm like, hi, in my 1 minute past. Time travels from future to past. That means my end is already determined. Or is it, or everything is like a group of files, and I'm traveling from one file to each other, I'm traveling from one page to each other, I'm traveling from one frame to each other. Crazy. More crazy stuff about the universe you need to know. Special relativity, time is relative according to gravity. Fourth dimension, three space and one time. You're in the fourth dimension is time. To visualize it, be in a room like full of mirrors. Let it be you're inside a room like a travel room. The door has a mirror. Behind that, the opposite side has a mirror. Your left side and right side has a mirror. Just make it everywhere, no? Your floor and the ceiling has a mirror. Like mirror all over. Let's say that's a pentagonal room, hexagonal room. Damn. Like multi mirrors would just like collapse your mind. Oh, sheesh. And time dilation, black hole. Then many more. To learn more, follow us because our next video is going to be space time, about the whole fabric. How, what is this fabric made up of? What are the things inside it? How did it all start? Big Bang Theory? I don't think it's even a theory because it's more so true, leading to the expansion of universe. Expansion of universe, yeah, universe is expanding at a rate faster. Get to know about them in the upcoming videos. Till then, stay safe, good luck, bye. And also, Happy New Year 2024. 1 year ago, you did something and the time went backwards, and you meet yourself in the you look at yourself in the past doing this, the thing, whatever you did. Bye.